Hello, and thanks for downloading Aerospace Testing International's monthly podcast, Testing Innovation. In this month's podcast, I talk to Anders Forslund, CEO of startup Heart Aerospace. So, without wasting any time, let's jump straight into the interview and find out what Anders has got to say about electric aircraft. With me today is Anders Forslund, who is founder and CEO of Heart Aerospace. Heart Aerospace is a Swedish company based in Gothenberg that is developing the ES-19 regional aircraft. What's different about this aircraft is that it is all electric. It is going to have 19 seats and will have a range of 400 kilometres. And recently they've been in the news for demonstrating or showing off for the first time the battery and powertrain technology that they're going to be using. I'm right there, aren't I, Anders? That was a couple of weeks ago.
That was, September 23rd.
Yeah, okay, great. So the company was founded in 2018, 2 years. So I guess you're still a startup. Could you just tell me a little bit first about your background and what led to the founding of Heart Aerospace? And tell me also, why have you called it Heart Aerospace? I was a bit curious.
Oh, that's a lot of questions.
Sorry. Go for
No, but yeah. So first off, my background is I have I was a PhD in aerospace product development. I did a research exchange at MIT. So I was there 2013, 2014. This was in the height of the sort of drone boom, and you'd have people like Elon Musk showing up and talking about electric planes. And I was pretty sure of two things. One was that electrification has a big future in aerospace, and the second was that it's probably not going to happen in Sweden. I probably need to move to California or to UK or Germany or something like that.
Sure.
Fast forward a few years, and our neighboring country, Norway, as like the first country in the world, goes out and say that they aim for all short-haul flights to be 100% electric by 2040. And that sort of changed my my perspective a bit. And I started, Sweden actually has a sort of proud history in both aerospace and electromobility. And we were like, can we set up something here? So we started the company Heart. We actually started it as a sort of a governmental research program, and then that morphed into Heart. Still get funding from the government. But we also sort of looked at like, what are the successful aerospace startups? What are they doing for fundraising? And we've seen a lot of them, like, Boom Supersonic, which was in the news, I think, yesterday. I don't know if you watched that.
Sure. No, I didn't watch it, but we covered it on the website. Yeah.
Yeah. So they were part of Y Combinator, Right Electric, and part of Y Combinator. So we're seeing that, aerospace startups, people that think, that are crazy enough to think that they can start an aerospace company, that's one place that they need to go, and that's there. So we applied. We were among like 12,000 people, companies that applied. We got in, and we started our fundraise in Silicon Valley. We were 2 people at the time. We got some LOIs from SAS and Bra and Vidare, so the Nordic airlines supported us.
Yeah.
We did a fundraise in 2019, and then we started growing a team. And now we're 12 people. Found some really high-level experienced people from the industry that's working with us.
Mm-hmm.
Our CTO is Nigel Pippard. He's former CTO of Saab Avionics. He was the head of electrical systems and avionics for the Honda Jet,
mm-hmm.
and a lot of other people that are sort of from the industry. So it's an exciting place to come to work.
And the name?
Yeah. So, Nigel actually asked me once, does it stand for hybrid electric aircraft for regional transport? And unfortunately,
stick with that.
Unfortunately, it doesn't. But it's a long story. I'll leave you with that right now. So
okay,
you'll have the scoop at one point.
We'll leave the mystery. That works. Yeah. Well. Okay.
Yeah.
So I mean, what stage are you at with the development and testing of the ES-19? At the moment.
So our aircraft. So first of all, our general philosophy with electric aircraft is not to sort of reinvent the wheel or try to build an aircraft that has a super long range or something like that. We want to build the aircraft that is being asked for by, say, the Norwegian government and the Norwegian airlines. And that's, today in Norway, they're flying Dash 8s. They're 30 years old. They're looking to replace them, and they're flying short routes. So just basically building an aircraft that doesn't, like, if we can achieve electric propulsion, that's one difficult thing. So we're not looking at doing sort of a advanced design or VTOL or anything like that. So we're building like an aluminum frame, high wing aircraft with 4 nacelles that contain the electric motors, also contains the batteries and the power electronics. So they're isolated in their nacelles, which also is a good thing for both like safety, fire safety, redundancy, etc. And so that's what we started with. So we built a mock-up, or not a mock-up, actually, a working prototype of that powertrain. So we built a state-of-the-art electric motor that's about 400 kilowatts, 2,300 Newton meters. And we've also built a battery pack. And most importantly, we built a power electronics, like a motor controller. And we put that together in a nacelle. And we built a test rig that's mobile, that sort of actually sort of resembles the nacelle on the wing. So it's a very much like, this is exactly the thing we need to build. And we're starting testing of that right now. So, I mean, it's going to be 5 years of design iteration, of certification, of testing of this stuff. But this is the thing that has the most sort of, has the lowest TRL level, if you want, or the highest engineering maturity. So we start with that. For the rest of the airframe, I mean, we're talking to the suppliers on that. We're building the organization so that we can support it and be the OEM and do the final assembly. But we're also working together with the sort of industry leaders in tier 1 airframe manufacturers and stuff like that.
Okay, so let me understand this. So I mean, basically, that's quite a different approach from other people. In that most people that I hear of, that everything is so in one self-contained unit, right?
Yeah.
I mean, a lot of people,
or in four self-contained units, yeah, that are identical. Yeah.
I mean, how are you dealing with cooling and things like that?
Yeah. So first of all, I mean, the most important thing to understand is that we are, if you're building a conventional aircraft that with conventional takeoff and landing, and you're putting a lot of batteries in there, you're building an all-electric plane with no like hybrid electric system or something like that. You put a lot of batteries there, so it's roughly the equivalent of 720 kilowatts is what we're kilowatt hours is what we're putting in there.
Yeah.
So that's a lot of batteries that help carry the load together. And the internal resistance of batteries, that behaves as such that that's proportional to the square of the current. So if you double the amount of batteries, you actually reduce the heat that's being generated by batteries by a factor of 4. So if you're doing something like a conventional takeoff, you're doing an all-electric plane with a high battery mass fraction, we're not seeing that much heating. So we're looking at different, like both air cooling and liquid cooling, but like for our tests, it's not like a huge deal. Like, and this is super important to understand, I think, because it's like, if you're, you also need to preserve cycle life. So, you need to optimize for unit economics. And if you're using a good cell with like a low internal resistance, even if it's not the most energy efficient cell, it will do the job, and it will actually be more on a pack level, more energy density.
Okay, that's interesting to hear you talk about that. One of the other things I was very interested to hear you talk about, talk about during the launch event for the powertrain a couple of weeks ago was the way that you made very clear that you felt battery technology was ready for this now.
Yeah.
Yeah. Thanks to the development that's happened in the automotive industry mainly.
Yeah.
And the plane will have a range of 400 kilometers, and some of the arguments around why that's important for sustainability were very clear as well. I mean, are there any? I mean, could you talk around the battery technology? I mean, do you feel like that's just going to keep getting better, or you're ready now?
Yeah. I mean, I think that it's so. I think batteries will get better. We saw the Tesla battery event was the day before our big event, so I sort of stayed up there and I was like, how does this change our equation? We also talked to a lot of battery manufacturers. I will say this. So the thing that we want to do is we want to build something that with the technology that we have today. And I guess at one point, like maybe 2 years from now, we're going to have to say, this is where this is the technology that we're going to certify.
Yeah.
But then there comes the other sort of aspects of it, which is, like you will never build a plane on batteries that will, be as good as a fossil fuel plane.
Yeah.
So we shouldn't compete in that category. We should compete in the other category, which is we can get, low noise, of course, but also better unit economics. So getting sort of some advanced cells that have a very bad cycle life, that has a very high purchasing price, that sort of beats the purpose of electric propulsion. Like if you have to pay an arm and a leg because you have to switch the batteries every 100 cycles, then you're not really competing the way you should be. So we're instead going to say, we're going to focus on the short ranges up to 400 kilometers, and start on the lower end. Start with the really short flights, and show that we can get superior unit economics out of this.
Mm-hmm. The other thing that occurred to me from the event was that you were very clear about the markets you were targeting, and that the aircraft would be able to operate from shorter runways, 750 meters long. So, I mean, already you're beginning to think about the market. Has that been important to think about marketing the plane and who's going to be using it from the start?
Yeah, I mean, it's super important. I think this is what the airline industry has done for so long. You need to focus on product market fit. I think, sort of electric aircraft, and especially coming from drone technology, there's sort of a hype cycle around it, I guess. And my first instinct as an engineer was also like, oh, look at all the cool things we could do with, VTOL and all that stuff, autonomy. But ultimately, I think I was like, yeah, but it's not difficult to I shouldn't but it's a lot more difficult to certify an aircraft than it is to build a prototype. Mm-hmm. It's a lot more difficult to, sell, get a working model of that. So we're instead just focusing what is it that the customers are actually requesting. And we seem to be finding ourselves in sort of an intersection where there's a large enough market for a 19-seater. The unit economics work, and the sort of technical feasibility of the aircraft is the technology is mature enough. So I really believe a technology, obviously I this is not the end sort of final stop of where electric aviation will take us, but it's the first step, and it's really important to find that first step and be able to rest at this first step.
Okay, good. Well put. Thank you. I'd just like to talk briefly about the actual testing and certification program. Yeah. I guess from what you were just saying about where you are with testing the powertrain unit, it's still quite early days, I guess. I mean, do you have a kind of firm idea of how the testing and certification program is going to go yet? What have you planned that all out yet? Or?
Yeah, I mean, we're definitely aware of the process. So we started. Had our first DOA meeting with the EASA in November last year. We had the pre-TC meeting. So we're definitely sort of very familiar with the road that lies ahead of us. We had EASA was actually even gave a little recorded speech on our event. So they're very involved. And But at the same time, we're in the conceptual stage, so we want to do rapid design iterations, and we built a motor that I think is super. I mean, we worked with the best suppliers. We built something that's super good, and I think there's nothing about it conceptually that is missing or wanting from sort of a quality point of view. But obviously, we need to go through that sort of certification phase and look through all of that. And most importantly, with the software, I mean, we've written all of our own software, doing it a little bit as a conceptual level. And now we have to sort of bring that through the sausage machine of bringing it to certified software. But I think one thing that we have learned sort of from a design philosophy point of view is that we've been very aggressive in doing stuff in-house. We built our battery pack, the BMS systems, motor controllers in-house. We've designed our motor in-house. We've had it built with a supplier that built the motor core. And this is like, we want to learn, like this is a learning experience for us. We want to learn exactly sort of what are the modes of failure, what are the big challenges, and not just go out and talk to suppliers and they sell us their black boxes. We don't like that. So I think we're going to gravitate. We're probably going to bring in more suppliers as we certify this, but we're going to keep the core IP and the core software ourselves. Okay,
great. I mean, it sounds very clear to me that you see the key challenge, obviously, as the propulsion system, and then not reinventing the wheel with the main airframe. Do you see any potential? I mean, what do you see as your biggest challenge, apart from in the future development of the aircraft? I mean, integrating the nacelles and the engines onto the airframe. I mean,
it's like a technical challenge. I just think that it's just like, it's an aerospace project, so it's like the weak link of the chain is what delays the program or poses the risk. Aviation is the safest mode of transport, and that comes with a lot of work. And so far, we're not seeing any sort of red flags that saying that you shouldn't proceed with this. We're actively looking for those red flags all the time. But there's probably going to be some unknown unknowns that's going to end up biting us at one point. But on the other hand, people, like, that's from a technical point of view. I think also the challenge of just being a startup and going into this industry and not just sort of not being like how do I say, just not doing it for more than a few years, establishing yourself, going through the detailed or the preliminary design phase, the detailed design phase, the production, financing your entire test flight program. I mean, there's a lot of, this is it's a expensive program before we started getting any revenue, and that's a big challenge. But we're seeing a lot of people like Boom Supersonic that are showing the pathway.
Okay, and as we were talking a little bit earlier about you were talking a little bit earlier about EASA and the challenge of certification. Do you feel like we've got the expertise within the company yet, or are you looking for people to deliver that certification of the aircraft the way that you want to?
Yeah, so I definitely think that the expertise that we have in our company right now, we're 12 people. We worked on 67 aircraft programs. Our CTO, Nigel, he was the head of avionics and electrical systems for the Honda Jet. He's done this, they walked this path many times before. So that's, I think, very comforting for me. We've also recently got some funding with some UK companies, including Baines and Simmons, on just the DOA process, the certification pathway for this. And this is, like my experience with it, I worked in the aerospace industry for a while. I did my PhD in the aerospace industry, but my experience, I know also the limitations of my own experience, and are very sort of approaching this very humbly. And this is sort of, you can build a prototype all you want, but it's, at the end of the day, certifying something is like, this is almost like 100% of the game, right? We're playing, so.
Right. Well, I for one don't think there's anything wrong with ambition, and I think your project is ambitious, but you seem to be approaching it in a very logical kind of step by step way, which seems great. I've just got one final question for you, really, and that is about the aviation sector and its approach to the environment and reducing its impact on the environment. Do you think that that the sector's doing enough? I mean, especially with the pandemic recently showing, people calling that we should come back from the pandemic with a more sustainable approach to aviation. Do you think there's enough calls for change, that the pace of change is quick enough?
Oh wow, that's a loaded question. Yeah. I don't know. I mean, I think that we're seeing a lot of good things. I applaud Airbus going on that zero-E hydrogen thing. I think that's maybe a smart idea for transatlantic flight.
Mhm.
I think we should never be content with what we're doing. We should always I think there's an extra level of we can always do better. and I think maybe there's been a little bit, like my background, working as a PhD, being part of the big European research projects, working with large companies. There's been a little bit of a, like, I don't know, focus on these sort of climate things as research projects, as academic exercises, which with a lot of actors, where there's almost like you almost get participation trophies on them. So I really like my personal preference, like that's why I work in a startup, is to set an ambitious, clear goal, and that's what we have. We want to have this aircraft certified by the summer of 2026. It's okay if we don't reach that goal, but it's not okay not to have a goal. And I think we should have those clear goals, and we should be held accountable for it. I think so that's one of the things. I don't like these sort of open-ended exploratory things too much, and so I want to set a clear goal, try to minimize the risk in getting to that goal, sort of wholly focused on reducing emissions from aviation, and not sort of in parallel do something else. So sort of having a laser focus on that. But I also see that we've been getting support from the Swedish government, from the Nordic governments, from the UK government, and now from the European Commission. So I think everybody's heart is in the right place. We just need to deliver on this, and that's a huge challenge that we all need to challenge ourselves to do.
Okay, great. Well, I can see you got a lot of passion, and I think that's that you'll need to draw upon that within the next 4 or 5 years. So that's great. But I wish you luck with your program. I'm sure we're thank you for your time, and I'm sure we'll talk again. We'll talk again in the future. Thank you very much.
Yeah.
So all that remains is for me to say thank you for listening to this podcast, and subscribe to our future podcasts on the website. Thanks, take care, and goodbye.